Well, peace, ladies and gentlemen. Welcome back to our galaxy.
All right. Yo, what's happening?
Yeah. Well,
What's
peace,
going
ladies
on,
and
everybody?
gentlemen. Welcome back to our galaxy and beyond with Anthony and JuJu. And we're going to get this party started off with, again, our mission statement. And also a little explanation, because if some of you have seen our first show, you are probably wondering why we changed the title. Well, we got some feedback and we didn't want to leave any room for any type of pseudoisms attached to the title and the reason for our show. So we came up with a much, better title, and also one that doesn't leave any room for any confusion. Welcome to our galaxy and beyond with Anthony and JuJu. And again, we decided to do something a little different, switch it up, change the narrative a bit on the current scope of conversation in the community. We also wanted to motivate and stimulate scientific interest among the people of our communities, especially families, with the hopes of positively impacting the lives of our children, who are our future and our legacy. This show, Our Galaxy and Beyond, will primarily be focused on the latest news and discoveries concerning the James Webb Space Telescope and all things concerning space science, our galaxy, and our universe. But of course, we may include other matters of science that we deem important or just fascinating. We also want to be a resource of scientific information, such as YouTube channels and other social media links providing access to science programs, space camps, training courses, events at your local university or planetarium, and anything that is generated towards allowing one to become actively engaged in increasing scientific literacy or training and education that could possibly lead to one becoming an expert in a science-based field or profession. And with that, welcome to season 1, episode 2, When Two Neutron Stars Collide. Anthony?
Yo, what's going on, everybody? Appreciate you coming out, tuning in. It's gonna be a good one. We have a great topic for you, and we're gonna bring some clarity, a little bit of clarity to it, as best we can. So yeah, let's get it in. You know,
Let's get it poppin'.
it's gonna be a great ride.
So, when two neutron stars collide, so we definitely wanted to touch on this topic because this actually was a recent event that just occurred with the James Webb Space Telescope, it detecting a kilonova. Of course, it's not the first time, but this is one of the times where they've had like irrefutable, substantial evidence and some other scientific gains from this particular event. I don't want to say discovery because kilonovas have, somewhat been detected in the past, I believe 2009 and 2013 by other means, because there are several methods when you can detect them. But we just want to focus on this particular astro phenomena and tell you some interesting things about the find, so to speak. So getting to the first part of it, so unraveling the mystery of under what conditions that many of our known chemical elements are produced. This includes elements of high value and even those that are vital to life as we know it. The answer to this question, at least part of it, may have just been discovered with the recent observation by the James Webb Telescope of a kilonova. This was considered a high energy event and the second brightest gamma ray burst ever detected. Also, a direct look at the creation of an individual heavy element from such an event, particularly this event. Um, this remarkable occurrence, a kilonova, is an astrophysical event that occurs when two neutron stars collide. Also described as a bright blast of electromagnetic radiation when these stars collide, or neutron star and stellar mass black hole merges. Those are the two ways that you get what you call a kilonova. Anthony, anything you want to add to that?
Yeah, it's what makes it so important is like what you said when you first started out is it answered a question. You know, we when you look at the when you're going through the periodic chart, you know, there's certain methods that we basically theorized at how these elements can be formed. And it was always theorized that, you know, neutron stars had played a big part in the forging of those, you know, heavier elements that we see on the periodic chart. So being able to actually witness this and, you know, using the capabilities of James Webb, you know, as far as the infrared, you know, it's visual capabilities, you know, they're able to actually see this happening. And when we get to speaking about spectroscopy and spectrometry, then you know that's when we'll get into the capabilities and you know how they were able to you know pull this off. But it's always been theorized. So that's a question that's been answered. You know, that's one we can check off because we have the observational proof of this event, and we being able to analyze the light, the gamma ray burst, which was actually pretty long. It lasted, they say, about 200 seconds. So that's pretty long for a gamma ray burst. But being able to analyze that light, you know, that's a major question answer. So you can
Nice.
continue, Ms. Juju.
Okay. So, a neutron star, which is the major focus of this conversation, is the result of the ultra dense core of a massive star that has reached the end of its life. This matter rich in neutral particles called neutrons. Neutrons are tiny subatomic particles along with protons that help form the nucleus of an atom. So I also wanted to maybe start getting into some visuals. Um, which picture would you like to show first, Anthony? The simulation of a kilonova, the real pictures from the James W. telescope?
Yeah, we can start with that one. But I want to say, you know, with
Which one?
the neutron, the the picture from Webb from the article,
From Webb.
but the neutron star, you know, that is a phenomenon within itself. You know,
Hmm.
it's actually the core of a very massive star. You know, a star more massive than our star, the sun. So it's when it gravity forces it, you know, to collapse, and it takes the gravity has to be is so strong that it pushes the electrons into the nucleus, of the atoms, which makes them neutral. And that force, gravity itself, is doing that. All that mass from that very, very massive star, which is you know much, much more massive than the sun, it all collapses down. So man, it's it's like I say, the neutron star itself is a phenomenon, and you get two of them to merge, that's even more major. Now this is the original picture. This is the picture from Webb, and you can see up there, the top left corner, that circle, that's the gamma ray burst that Webb detected or observed. It didn't detect it; it observed it, and that's
Mm-hmm.
the galaxy, the host galaxy, where the two neutron stars, actually flung themselves out of the galaxy, if I'm not mistaken. And I can't remember
Correct.
how far away it is, but it was the gravitational effect that they have on each
120,000
other.
light years away.
Yeah, so that's pretty far. It's 120,000 light years. We talked about light years last week. That's 186,000 miles per second. You know, so something moving across 120,000 light years. If it takes light to move that, 120,000 years, just imagine how long it's going to take us. So that's, like I say, that's a great shot right there. But which one? What's the next one you got there, Miss Juju?
Well, on the show, make sure you have a pen and paper out if you want to take notes. Like you can archive this. This will also be archived on Pseudo Killer's channel. And again, just to remind folks, don't forget to check out the description box of the show. I've placed some amazing links in there, and particularly the articles that we use as our source material for the show. It was a lot, right? It's a lot to it. Anthony warned me when we started this endeavor for these shows that it was going to be a lot. So we literally ourselves, well, myself, are biting off nibbles in order, just just to feed you, just to feed the audience, and just to let people know, Anthony is my teacher, so to speak, in this endeavor. So every time we do a show, I'm in class. Every time I have to go research any of this phenomena, like I go into it not having a clue what it's about, but coming out of it learning a great deal and feeling very confident that I've conceptualized and mastered that particular piece of information. So that's the fun part about it. So I'm going to give you a little bit more to eat on when we're talking about gamma ray bursts. So gamma ray bursts, and usually they refer to them as GBRs. And the particular gamma ray burst that was detected by James W. Webb Space Telescope, it actually has a name for it. It's gamma ray burst 230307A. And like we said, the kilonova, you have these two stars, but the stars get pushed out of the galaxy, and it was a spiral galaxy 120,000 light years away from the spot where the gamma ray burst was detected. And I think that's phenomenal. And then there's also a process in which these stars go through, not only to become neutron stars themselves, but even to become a supernova phenomena. So with that said, I was going to go ahead and share the supernova simulation artist rendition. Anthony, is that okay?
Oh yeah, yeah. You can go ahead and play that, and then I want to, after you do that, we can shout out the chat. My bad, family. I'm gonna get
We're gonna take a commercial break. Don't you worry, okay? And again, we do thank you for the support. We think all of those who took the time out to be here and support us and to also gain some new information. Okay. Give me just
But
a moment.
it's like I go ahead, Ms. Juju. But it's
No.
this subject, astronomy within itself. I mean, it's fascinating to me, but it's so many avenues, to go down when it comes to astronomy. You know, it's my love, of course. Y'all know that because I say it enough. But we there's a lot of questions that's being answered with this James Webb Space Telescope. I mean, it's raising new questions as well. But you know, this instrument here, this tool that we have, man, we got to take advantage of it. It's like I say, we got to take advantage of it. So I
Keep
wanna, while
talking.
you getting that together, Miss Juju, I'm gonna shout
Yeah.
out the chat, brother Brass. Appreciate you coming through. Kent, appreciate you giving us the keys to the tank again, old boy. King Sosa, peace to you. Um, Miss Felicia Bennett, thank you for showing up. Peace to you. Real thoughts, 910. Mungo Slade in the house. Keenan Wright, appreciate you. My name is Tika. My name is Tika. Thank you for coming through. Ronald Perkins, what's happening, my brother?
Yeah.
I'm gonna get to that question. I got your question. I got you. Uh, Clever Speaks TV, thank you for showing up. Gideon Block, my brother, what's happening? Marcus Chilimboy, peace to you, my brother. Jody Breeze, what's going on with you? Sister Safa, thank you for showing up, baby. West Africa YDNA, EM, EM2, peace. Pure Black, peace. Appreciate you coming through. Giles Herbert, peace to you, my brother. Uh, Mac Rob, what's happening with you? I want to thank everybody for tuning in, showing up, and we're going to keep this thing going every Wednesday, 7 p.m. Eastern Time, 6 Central. It's going down. We already got two more shows lined up, so we ready to go.
Already. So I just wanted to continue a few more notes for you all. Quick pictorial demonstration of how a kilonova comes to be. So the other significant piece of this puzzle was actually the detection of a chemical element when observing these gamma ray bursts. The heavy element discovered in this particular kilonova is the chemical element tellurium. The ejected matter formed from these merging events, or that formed the kilonova, is responsible for over half the elements located in our periodic table. Another element near tellurium on the periodic table is iodine, which will most likely be later detected in this event by the James Webb Space Telescope scientists. Other elements significant from this process are neodymium, which is used for our cell phones, and molybdenium. I did practice, y'all, I swear.
Mhm.
Molybdenium, which plants rely on as a central component in an enzyme that helps them to fix nitrogen from the air. And also iodine, which is essential to, um, essential to us as humans in some of our bodily functions and or processes. some things I wanted to get into about tellurium so you can better understand this particular element, and also some of the value that it has to us as humans on Earth. Um, is for one, tellurium, again, is a chemical element with the symbol Te and the atomic number 52 on the periodic table. It is brittle, mildly toxic, rare, a silver white metalloid. It is chemically related to selenium and sulfur, all three of which are called chalcogens, occasionally found in its native forms as elemental crystals, far more common in the universe as a whole than on Earth. Its rarity is compared to that of platinum. The most common use for this element, tellurium, is actually in solar panels. They call them CDT solar panels, and um, the thermal and excuse me, thermoelectric devices. Sorry. It's also considered to be a technology critical element, which I found to be, duly important also. Not only is a rarity, but we also need it for many things that are considered uh, uh, technical technology tools or whatnot because of its component and its structure or whatnot. So
Mhm.
now for the diagram on the screen, this is actually somewhat a pictorial simulation of a kilonova. Did you want to say a few things before I get into it, Anthony?
Yeah, this is a pretty good diagram here, and this kind of goes into Mr. Birkin's question. Now, the particular event that James Webb photographed was pretty much a system like this. Yes, it was binary. It was two massive stars, just like it is on this chart. So this is actually pretty good work there, Miss Juju, with
Thank
this right here.
you.
And it explains how that process took place. You know, you had two massive stars. One of them goes supernova first and becomes a neutron star, and then it begins to siphon gas from the other star, which wasn't quite as massive, because the more massive a star is, the quicker its life cycle goes. And that's all due to gravity, which we'll get into that, I guess, maybe season two. We'll dive into
Yeah.
stars, but
Season
that's
two.
basically that's basically what's happening. You have one, the more massive of the two in the binary goes supernova first. It forms a neutron star, and then it begins to, siphon off the other, and which makes it unstable, and it becomes a neutron star. And them those two stars, the neutron stars, they continue in their orbit, eventually getting, over time, getting closer and closer to each other until they merge. And that's when the kilonova is formed. That's when you have the kilonova. So, or it could be a neutron star with a black hole. That's been theorized as well. But like I say, this particular one, it was two neutron stars, and that another, avenue we can go with this is getting into the nebula theory or hypothesis about, how our solar system formed. And being that we have those heavy elements, especially here on Earth, when that nebula that formed our solar system, when it came together, there was probably one of these events going off, or several of them, who knows. because we find those heavy elements here on Earth, and that periodic chart that we're going to show you guys, is dope. So all of this stuff we putting up, you need to grab it. I think we have links in the description as well.
Yes. So yeah, I do have the links, it's particularly to the NASA.com. And, I promise you all that when we do the shows every week, I'll be providing you links. And in a minute, when we get into our commercial break again, I'm definitely going to share some links to you and some information about those links. But again, it's a lot of information, right? For the sake of the show, and not overwhelming people, not overwhelming myself particularly, but people who want to get into it, and this can be a very intimidating subject matter. We wanted to keep the shows at a minimum, not exceed a certain time, and just give bits of information. But by doing that, that also makes for more chances to have more shows where we would pick, a particular phenomena that we may have spoken about in the past and go in depth in, one step at a time, one, astrophysical phenomena at a time, pretty much. And that's how we want to do it. So Anthony just explained the process, but like Anthony is on a scooter, on a motorbike, and I'm on the sidewalk walking when it comes to this information. So I'm going to do it really quickly using the diagram. And also, if you follow along with me in the audience, to give you a crystal clear picture exactly on what we're talking about right now. So this, if you can see my arrow, is figure number 1. And figure number 1 is 2 massive blue. They also refer to blue stars as B stars in astrophysics. So these are 2 B stars or blue stars form in a binary star system. And of course, binary is like a 2-star system. Am I correct, Anthony?
Yes, yes, it's a binary. It's 2 stars. You have trinary. I mean, it's triple star systems and all kind of stuff. But yeah,
Right.
that's double star system.
Double star system, binary. So, and figure 2, which is this figure here, if you all follow my cursor, so this describes the large 2 stars reaches the end of its life. So that means this larger star is somewhat turning into a neutron. I think I read about the neutron earlier, how the neutron is actually, when the star comes to the end of its life, and then it has like this dense mass and these neutral particles or whatnot within the dense mass.
Yeah.
And then, so this would be like, go
I'm
ahead.
sorry, Miss Juju. But yeah,
You're fine.
that's when well, you said it right. You were correct. The neutron star, it when the massive star blows up, and we're gonna get into all of that. The types of stars, O, B, A, it's a bunch of them, but very massive. It's not quite massive enough to become a black hole, to form a black hole, but the neutron star is like the next step after neutron star would be a black hole. So yeah, you correct.
Okay, and I blew it up a little bit. Maybe people can see it better. Let's see if this can work. So, and then 3, which is this here, and I'll move the screen over a little bit for you. The smaller of the 2 stars siphons off material from its larger, more mature companion, stripping it of much of its outer atmosphere. And this is figure 3. So the small star is siphoning off the atmosphere and material from the larger star. So that's interesting, Anthony. So basically, in this occurrence, the large star is actually the vulnerable one in this occurrence. Am I correct? Somewhat, so to speak.
Yes, yes. I think I may have said that backwards. But yeah, what you're saying is correct. I mean, that's what the article is stating. So I think I said it backwards. So forgive me for that, people. But yeah, that's what happens. You get one star begins to siphon off the other, and that's when the unbalance begins and all the chaos starts.
And then here in figure 4, the large star forms an ultra stripped supernova. And that's something we'll get into another show, talking about supernovas and novas and all those different things. Something that we'll share with you. It's also in the two sources, the articles that I've shared in the description, is that in order for you to even get to the point of the kilonova, you have to go through the stage of a supernova. So the largest star forms an ultra strip supernova, the end of life explosion of a star with less of a kick than a more normal supernova. Then stage 5, which is here, as currently observed by astronomers, the resulting neutron star, um, which I believe is this right here, the resulting neutron star from the earlier supernova begins to siphon off material from its companion, which is this one here, turning the tables on the binary pair. Then figure 6, with the loss of much of its outer atmosphere, the companion star also undergoes an stripped supernova. This stage will happen in about 1 million years. And
Yeah, no,
then
that's
I might
deep.
have,
That's
right,
that's
right, right.
that's pretty deep right there. You know, you take maybe about 10 times the mass of our sun, and that's how and you compress it down. It's I think they say a neutron star is about the size of an average city, so about 12 miles in diameter. So you taking all that mass and compressing it down to something so small. So yeah, I think in the diagram there in 5, that little bitty dot is the neutron star compared to its companion star. So, for me, that's pretty deep when you can get gravity to compress something so massive down to such a small radius. That's pretty deep. Sorry
And then
about
where
that
I'm at,
interruption there,
7.
Juju.
No, you're fine.
Yeah,
7 is right here. Let me see if I can make it bigger so you all can see it. 7 is this right here. So this actually
yeah,
is the showing of 2 neutron stars. And 7, a pair of neutron stars in close mutual orbit now remain where once they were 2 massive stars or blue stars. And then 8, which you have here, the 2 neutron stars spiral towards each other, giving up their orbital energy as faint gravitational radiation. And then for 9, which is the phenomena that we're discussing now, you have the kilonova. The final stage of the system, as both neutron stars collide, producing a powerful kilonova, the cosmic factory of heavy metals in our universe. And that, ladies and gentlemen, is a pictorial simulation of how you get a kilonova.
that's
Anthony,
what's up. That's what's up, Miss Juju. I appreciate that. Um, could you put up that periodic chart?
absolutely.
I wanna show that periodic
Mhm.
chart.
So
But this
you
particular
might have to
chart
give me
here,
a few minutes on that.
yeah, that this particular chart that she's bringing up, it basically deals with, astronomy and cosmology. Um, well, not so much cosmology, but how the elements are actually forged. What processes took place, for us to get these elements. So this one will be a good one, especially if you're into astronomy and cosmology. This will be a good one for you to have when dealing with like the Big Bang and the like I say the forging of elements, because those elements are actually forged in stars that we know of. So when we get this chart up, that'll be y'all need to put this here one in your files. And let me see, Ronald Perkins, are supergiant stars more inherently less stable than stars on the size order of our sun? I would say so, yeah. We can, you know what? I'm gonna pull up some information on that and get with me in the chat on this show in the comments. I mean, after the show, and I have something for you on it. But I would say yes, because a supergiant, when the star becomes a supergiant, it's in the final phases. It's depending on the depending on the mass of the star. It's probably gonna supergiant is probably gonna go supernova. Those are massive stars to begin with, like Betelgeuse. Um, that's one everybody's got their eye on. Antares, which is Betelgeuse, is in the Orion constellation, and I think Antares is um, no, Arcturus is in Scorpio. That's one. Antares, I believe, is in Taurus. Not 100% sure on that, but y'all can check me on that. Those are, pretty good examples of supergiants that they predict will go supernova. Now, a star like our sun, which is a G-type star, it's not as massive. It's not, as hot. It only will reach the red giant phase, so it won't become a super giant. But as far as being stable or unstable, I would say our sun at the moment, because it's in the main sequence, it would be more stable than a supergiant, because a supergiant could go at any moment. So that would be my answer. But I'm gonna, like I said, I'll get with you in the chat and see if I can drop some sources in there. If not, you need to get into that Discord, man. We got plenty of stuff in there, you know. But yeah, get I'll get with you in the comments there, Mr. Perkins. Be looking for that. See if we got any more questions. But yeah, like I was saying, we already got our next two shows lined up. So yeah, y'all make sure y'all be in the building. And if y'all wondering, yeah, I'm sitting outside at the moment because the sun getting ready to set. It'll be dark. It'll be nice and clear. Got my baby right here. Yeah, we're gonna get it in tonight. We're gonna get it in. Let's see what we're working with over here. See if y'all can see this. Okay, this my Celestron C6, which is a Smith Cassegrain. Pretty good telescope. I love it. Putting in some work. About to tonight. This my mount. HE HEQ 5 Pro from Skywatcher. Pretty good mount. It's rated at about 30 pounds. And this my camera right here. This is my main camera. That is a ZWO 533 MC color camera. It's made, you know, for telescopes, but you can also put a camera lens on it. They have adapters for it. And this right here, this is my guide scope, with also has a ASI. This is a 185 MC camera on it. And what this does, it guides the mount. It tells, it locks on a few stars, and it tells the mount. Well, actually, it sends the information to this little computer right here. So this is a ASI Mini. It controls everything. It controls the cameras. It controls the mount. So now all I have to do is plug it up, set my parameters on what I want to do, and go in the house and lay down. So shout out to my boy DQ Hampton. We had to upgrade, baby. But yeah, that's what I'm getting ready to do tonight. So probably go after. Still trying to decide. I don't know. Probably go after a globular cluster, or maybe Orion Nebula, something like that. But it's going down tonight. So y'all be looking for some new pictures coming in. We looking for some new pictures because I hadn't had a chance to really do anything because the weather's been so bad. But yeah, it's going down. And I don't know, we'll get some shots of some planets. Yeah, think we can get Saturn
I think it's time for us to,
and Jupiter. Yes, ma'am.
I think it's
Yeah,
time for us to take a commercial break real quick. And when we come back, we will go over that periodic chart, if that's okay with you.
yes,
So,
ma'am. And y'all make sure y'all hit the like button,
so let's go ahead.
share and subscribe to the show. Do that for us. We surely would appreciate it.
Yes, and during this commercial break, also, I wanted to share with you all some new links and let you know a little. And the first one is the Pale Blue Pod. And remember, these links are in the description box. So please make sure after the show that you go to that description box and you pick up these. And the European Space Agency, those are those are our link shares for this week, season 1, episode 2. The Pale Blue podcast is an astronomy podcast for people who are overwhelmed by the universe but want to be friends, hosted by astrophysics Gupta. The goal is to demystify space one topic at a time, and new episodes air every Monday. And the reason why I did pick this particular podcast is, for one, if you've been following serial killers, especially our interview with the experts, Moya McTeer was one of the astrophysicists that we brought onto the platform and had the amazing opportunity to interview. And she is pretty amazing. And she's also a sister. So I thought that was pretty hot. So definitely go out and check Moya McTeer's podcast. And also, the next one was the ESA, which is also the European Space Agency. And I picked this particular entity also for a few reasons. One, because the James Webb Space Telescope is heavily entwined with the European Space Agency, along with the Canadian Space Agency and NASA. They are the three entities that came together to actually build and produce the James Webb Space Telescope. Not only that, but I actually follow ESA on YouTube, have been for a few years, and I'm telling you that the information that they offer and submit is pretty amazing. Not only is a YouTube page pretty awesome, but also their website. So please take notes, take these down. Please share these links with your friends, your family, and your children, and again, become actively engaged. And also, uh, again, we want to give a shout out to everybody that has joined us this evening. I'm going to shout out, we got Community of Skeptics in the building. Thank you. Rock City, New York. My sister, Gemini the Goddess. Thank you for coming. Also, Brother La in the building. Uh, American Dream, we appreciate you. My sister Tika, what's up? I know he shouted you out earlier, but I just wanted to show you a little love. And yeah, that's where we at with it. So again, those links are in the description box. So head over there after the show and check them out. So Anthony, are you ready to get into this periodic chart situation, sir? It's all yours.
Okay, yeah, we wanna
Or maybe not.
take this. Can you hear me? Can you hear me? Can y'all hear me?
I can hear you.
Okay.
Yeah.
Yeah, this chart
Yes,
here,
sir.
yeah, this here is a pretty dope chart. You know what I'm saying? If you can, Miss Juju, could you blow it up for the people? But it
You
basically
asked me too
explains
much.
it it's basically it's color coded, you know, to correspond with, you know, the process that creates these elements. You know what I'm saying? So if you look at the very top left, you see hydrogen. That's number one. You know, we was taught that a long time ago in school. That's the most abundant element in the universe. And you see, if you look into the key, the blue is that happened by Big Bang fusion. So the hydrogen has been here. But if you pull over one block and down, you see the merging of neutron stars. And when you look on the chart, you see all these heavier elements. Now, iron is the, I guess you could say, the final death knell for a regular star. It's going to make it go supernova. And we'll get into those, which then forms a neutron star. So when you get the merging of those two neutron stars, that's how all those elements with the purple are forged. And if you look over, all the way over, let's see, that's one, two, what the third column from the far right, you see that TE. That that's the element that Webb detected in that photo using the spectroscopy, which is taking the light and breaking it down into its basic, you know, into a spectrum. And that process leads you to spectrometry, which is the application of the information you receive from the spectroscopy. Each chemical element has its own separate, you know, spectrum. They're all different. It's like, you know, your fingerprint. Everybody on the planet has their own separate fingerprint. So that's how it is with the chemical composition. And when you take that light and you split it into its various, you know, colors, you'll come out with that spectrum. and you'll have what's called absorption lines. Do we have that picture, Ms. Juju, of the elements, the three elements on it?
Sure, if you're talking about
But if you like I say, each element has its own unique composition or unique spectrum. So that's how they can tell, you know, what element it is based off that spectrum. So this chart tells you how those elements are forged. And when you get into the spectroscopy, it'll tell you how those elements are detected. So this is a really good chart. Like I say, you can screenshot it or whatever you may, but you need to have this here one in your file. 'Cause this one, with dealing with astronomy, this here one is pretty dope. It's a pretty good one. So yeah, let me see if we got any more questions while you doing that, Miss Juju.
Well, before I go, I just want to let the people in the audience know that soon enough I'll be having some new technology because actually having some technological difficulties. My hardware is not a fit. You know what I'm saying? I didn't think that I would be doing a type of show like this, so I'm working on it and we'll do better. But I've been trying to blow that screen up, I swear, but it's about to kick me out
Oh,
of the StreamYard, and I didn't want to cut the show, so I left it alone. So my apologies, but
okay, that's fine.
I'll get you them links, people, and you can
It
see it
that,
close up. So don't you worry, okay? Don't you worry. But I'm gonna go
that
and pull up a few more pictures for you and close some of these tabs and we'll get back to it. I didn't know if you wanted to explain a few things or play a DQ
well, I'm gonna
song
ask
and people to
Miss
hit that
Gemini real quick.
cash out.
Yeah, y'all make sure y'all hit them cash apps and make sure you support Abjuwell. That's my man now. I got my Space Age African hoodie on right now. So, yeah, make sure y'all get in that Abjuwell. And but to Miss Gemini the Goddess, peace to you, my sister. So iron is Fe. Is there a connection to the word female? Uh, Not that I'm aware of, but hey, in your world you can do what you please, baby. But nah, jokes aside, no, I'm not familiar with anything like that though. So yeah. Any more questions in there? Yeah, peace to you, my sister. Peace to you. It's Gemini the goddess. So all right, well, that's while Miss Juju looking for that last slide there, we're gonna entertain y'all with a little DQ. Oh, I probably can't do
Yeah,
it.
you are. It's DQ, baby. Pseudo killers, what up? What up? What up? Check. Tapping in, what's the subject? Evolution or revolution, we ain't done yet. Laying flat like Sanchez, this a bomb threat. I know my flow like Angozi. Source up and show me, homie. You shut up and mute up a moment.
Anthony?
Mad scientist, I'm knowing all the components. We own it, and we gon' off.
You got it?
Are you gonna play that DQ? No, are you gonna play that DQ song or you can't?
Oh, y'all couldn't hear it? It was playing. Um, hey,
I can't hear it. I'm
I don't
sorry.
know what happened.
Carry on.
Hmm. All right. Well, anyway, yeah, we swerving a little bit in the tank tonight, y'all, but bear with us because I promise you it's gonna get better with every show. You know, each show gonna get better. So y'all just bear with us. But how y'all feel about that information? Y'all pretty straight with the information? And we put the link in the pseudo killer Discord. So if y'all want to jump on, got any questions, y'all want to jump on, come on with it. Yeah, Mr. Perkins. They have a there's another telescope they have out in space. It's called Swift, and it's actually designed to detect gamma ray bursts. So it was actually Swift that detected it first, and then every all the other telescopes were pointed that way. But it was Webb that actually took the photograph and did the light spectrum or the light analysis on it. So that's pretty much how it went down. But it was a collaboration of a lot of instruments, here on Earth and out in space. So yeah. Let's see, does FE have anything to do with female? Like, nah, we ain't gonna do that. Oh yes, ma'am, Miss Gemini the Goddess. We got you every Wednesday. It's going down. And y'all make sure y'all hit that like and subscribe and share the video. Send it out to your people. Well, Miss Juju, we knocking on an hour right about now, so we can deal with that other picture there in the comment section. What you think about that?
Um, I actually have something for you.
Okay.
It might be backwards, but start here and then you you can work. And then I'll go through some notes and we'll take some questions. Do 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 do.
What's happening with you, my brother Marcus? What's going on?
What's going on, Big Anthony? Juju, how y'all doing?
Man.
Oh, man, I ain't gonna complain. It's getting a little chilly out here in my neck of the woods, but that's what I do.
Yeah,
You doing all right?
yeah, I'm doing good, man. I just wanted to show my appreciation for the show y'all doing, man. I'm learning so much. I'm grateful that y'all took the time out to, explain these concepts to us, man. I really appreciate the work y'all doing.
Man, I appreciate you, dude.
Thank you. And thank you
That's
for
a
the support. I appreciate that.
uh, yeah, that's major, man. And like I said, I like to shout you out, Marcus, because you've been down with me from day one. So yeah, man, much love to you, and I appreciate it. I really do, bro. I appreciate your support.
So I'm gonna get on back out of here, man. I just wanted to, show some love, man. I really
Okay.
appreciate it. So
All right, appreciate you, bro. And Mongo, we're gonna keep that a secret, bro.
So
So
I'm having
yeah,
technical difficulty. We might not be able to share those other photos, but we would definitely make sure that we have them for you the
hmm
next show. I promise, Girl Scout Honor. Um, but yeah, my
yeah, those pictures, Miss Juju, they can
equipment does
they can
not.
go with they can go with every subject. You know what I'm saying? So we can use them every week if we really wanted to. So yeah, we got them.
Yeah, yeah, I'm having difficulties loading and I don't want to lag the show. So we're going to touch on both of those subjects on the next show. Both pictures. One was absolutely beautiful. I'm so upset that I can't get that up. But maybe before we end the show in a little bit, we can actually go through some of that. there were a few more notes that I wanted to kind of go through with the audience, and then you can do some more explaining. Then maybe I can get those up. But in the meantime, I definitely have this image for you all. So I'm going to share that and let you feast your eyes on that while I give you a rundown on a few more notes. And that last piece was actually the last picture I'm sharing is actually an artist rendition of a kilonova simulation. So by observing kilonovas, we can detect the origin site of these elements. So we spoke to you about, kilonovas and these astrophysical phenomenons, basically being the I want to use the proper words, Anthony, but someone of the creator of these elements that we have within the universe and here on Earth, right?
In
And
in the field they say forged, so we want to use that terminology. Those
forge,
elements were
forge,
forged.
yeah.
Yeah,
'Cause
there
I
you
want to
go.
get away from like using create and all that stuff because then people are like, well, who created it? And then it was intelligent design, and we're not doing that. So yeah, forge. So by observing kilonovas, we can detect the origin site of these elements, forge, and measure how they were formed. So here was an interesting piece that was in the source material. So the main obstacle to this with scientists is that they still don't know how the elements are formed in the merger process and the nuclear and particle physics acquired for the alchemy to occur. So even when I read that, I thought, dang, they're using alchemy. But so they're basically having an issue understanding the physics, just
Mhm.
so how can you have this phenomenon, then you can get these, you know, all these different types of elements. So what I did read and I came to understand is that iron is a heavy metal, one of the more denser ones, but you also have metals that are even more denser and heavier than iron, and then you have some that are less. So it also has to do in these processes something about the neutrons. You know what I'm saying? The elements either losing neutrons or gaining them, and then that changes the component of them, you know which is fascinating and a whole nother show that we can actually do on just that. But that was the major significance of this discovery with the James Webb Telescope, that they were able to observe this astrophysic phenomenon, and that they were giving some phenomenal fundamental clues on how the elements that we know today came to be. And that's a big step. Kilonovas are very difficult to observe due to the rarity of their occurrence. So we can protect them by the GRBs. Remember, I discussed GRBs in the beginning of the show, the gamma ray bursts. So short GRBs usually last only 2 seconds and can likely be the byproduct of these infrequent events. So earlier I explained to how we have this kilonova event, but this is not the first time, nor the first time we may have observed one, because they do have some ideas. They probably observed the kilonova by other circumstances back in 2009 and back in 2013, I believe. But long GRBs or gamma ray bursts last several minutes, which this one did. So this particular GRB, which I let you all know earlier, which was labeled 230307A gamma burst, that's its name, was quite long, on lasting for 200 seconds, which is phenomenal when it comes to gamma ray bursts. And this gamma ray burst was detected by Fermi. And this is another note taker for you all. When we start to get into all the instrumentation in the satellites that are used, how shall I say, used together with each other to make these discoveries. So you have one instrument that can do this, and then you have this other instrument that can do something a little different. So these next few notes are going to be explaining exactly how that happens. So Fermi is a powerful space telescope and observatory, particularly engineered to detect gamma rays, which are considered to be the most energetic forms of light. So once this gamma ray, GRB 23037A, was detected, another piece of scientific space technology was introduced to help make further observations. And this other piece of equipment is called SWIFT. SWIFT is another space observatory and satellite that detects gamma ray bursts and other cosmic objects and events. SWIFT houses three multi wavelength telescopes collecting data in visible or optical, ultraviolet or infrared, X ray, and gamma ray light. SWIFT was used to pinpoint the source of the gamma ray burst 23037A, the second brightest observed in 50 years. Do you have anything to say before I go on?
No, you keep going, Miss Juju. You cooking. You cooking.
Yeah, right. So, how a kilonova is born? We just gave you all an oral and a visual explanation from the source material. Um, so we kind of went ahead, but I thought that was important that y'all can kind of understand how that works. Also, one of the third and not the final, but I think the most important piece of this, and because this is particularly what our show is based on, James Webb Space Telescope and its participation in these astrophysical phenomenons. The James Webb Space Telescope, it's NIR cam, which means infrared camera, and it's NIR spec, which means near infrared camera and near infrared spec. NIR cam, NIR spec. Um, Both of these help to unfold all the pieces. It detected materials being ejected at high speeds, but also detected light being emitted by the chemical element tellurium. And dang, I wish I can get the spectrum chart up. Oh, oh,
But
I got something.
that near spec, that's the spec the spectrograph
Ooh,
that's actually
ooh,
on the near infrared camera. So there's a camera, and then the camera has the spectrograph on it as well. So that's what I was speaking about earlier. That's how they get the information that they need to determine, what they're looking at. So it's the
I got a
spectrograph is
surprise for you,
built into
Anthony.
it. Okay, break it down for
Uh-oh. Uh-oh, Anthony. Oh,
yo.
oh,
Unc want the link. We put
oh.
the link in the admin
The
chat, Miss
link is in
Juju.
the Discord community of skeptics, in the mod chat and in the admin chat. Because if I do too much, I'm going to
Okay.
kick us all out of here.
Okay, there we go. Now
Here
this is
we
what I
go.
was speaking about. This is what I was speaking about, the how the elements, each one has their own, unique signature. And when you look at that spectrum there, you see those dark lines, those are called absorption lines. So that light at that particular wavelength is being absorbed. And if you look there, you see carbon, helium, and hydrogen. You see they all have those lines, but they're all in distinct places. So each one of these elements, where you see that black line within that spectrum, that means that the light is being absorbed at that particular wavelength. And like I said, that's the signature for for the element. So that's how they can tell. And this is what that near spec, the spectrograph on James Webb is giving them. So they're getting this information instantly. You know what I'm saying? It's happening as the light hits the camera, they're getting this information at the same time. So that's what the technology of Webb is doing, you know, for us today. So that's why it's such a major advancement in science and for science. You know, it's man, it is amazing. So that's your tax dollars at work. But that's basically what they're trying to do. They're trying to figure out what's what's happening out there and how these processes are taking place. And science is answering those questions. Webb just answered a question. We like I say, we always thought and theorized and you know l- logically put together that how these elements are forged. Well, now we have the visual proof to go with it. So there you go. Webb is a beast. Yeah, it's getting dark out here now, y'all.
Web is definitely a beast. So, since you're talking about all things specto, so I'll go into spectro. Say the word for me, Anthony. I practice this too. Spectroscopy, excuse me, y'all. Spectroscopy is the branch of science concerned with the investigation and measurement of spectra produced when matter interacts with or emits electromagnetic radiation. And then we have uh, spectrometry.
Yeah,
Spectrometry
spectrometry.
is say it again.
I say, yeah, you said it right. It's spectrometry.
Yes, I won. Spectrometry is the measurement of the interactions between light and matter and the reactions and measurements of radiation, intensity, and wavelengths. And I also put a note to explain the difference between these two, spectroscopy and spectrometry. I mean, I know, but I didn't know if you want to go ahead and explain it.
Yeah,
Um,
yeah, you can do that. I touched on it a little bit, but yeah, you can actually
you
read
did.
the definition. Yeah,
Well, a simple put. So, a spectrometry is somewhat what qualifies or quantifies spectro spectroscopy. Okay, so
yes,
spectroscopy is like what it is. The spectrometry is what measures the spectroscopy. Simply put. Um, Also, the uh, James Webb Space Telescope. I can't figure out if I want to do the acronym or say it out loud, but I'm just going to say it because I love it. Also helps to determine the original location of the neutron stars responsible for this kilonova. And I told you all before, it's 120,000 light years away in a spiral galaxy. Beautiful. And actually, I think that I might have a picture for you. um, for this particular for this particular. Well, I'm gonna let Anthony explain it once I get it. I hope it doesn't fail me yet. Um, but like I said before, the last note with the James Webb Space Telescope is that it was a joint endeavor between the European Space Agency, a Canadian Space Agency, and NASA. Pretty much an international project, and probably one of the most phenomenal pieces of scientific equipment to date. I will say that, but while my computer wants to take 1,000 years to load, and we have one more beautiful, phenomenal piece of visual stimuli for you, I'll leave you with this. The future of James Webb Space Telescope seems endless, and its ability to possibly discover even more heavier elements is exciting. As quoted in the source material in the description for you all. James Webb Space Telescope is solving mysteries of our solar system, looking beyond to distant worlds around other stars, and probing the mysterious structures and origins of our universe and our place in it. And this right here is something that Bobby Binger and I actually touched on, I believe it was yesterday, when we spoke on cosmic perspectives. So, like, while all this crazy stuff is going on in the world, nothing changes the ultimate reality of who and what we are and our ultimate place in the universe. Nothing changes that, you know, and not to, I don't want to come off brass or don't want anybody to think that, you know, there's no meaning to life. But when it all boils down to it, we're just a speck of dust. I'm going to use yours, Anthony, and I will give credit. Concrete Corey used to say this. How should he say we're just a speck of dust on a speck of dust? So, you know, whenever we're going crazy about things, like, just remember, you know, it could almost be considered serendipity for that, and not get caught up in all these quote unquote social constructs or this tribalism or whatnot. You know, we're human beings, and we're lucky to be, you know, organisms that are living and surviving. We also talk sometimes that natural selection doesn't choose us. You know what I'm saying? Doesn't work to choose us in any way, shape, or form. And we should be mindful of that all the time, and be grateful. And for the last piece, I got it. Only took 30 minutes.
Before you do that, I just want to say, I appreciate that was brother Corey used to say that all the time. And, you know, it's so true. When you actually dealing with the universe, you realize and understand that, hey, I'm I'm just a speck of dust on a speck of dust. I mean, that's the best way to put it. You know what I'm saying? And um, what was that? My boy Gullah. I agree with you. Yes, we are a beautiful mistake. Just we're a byproduct of all these forces and
I
things
like that.
happening in this universe. We're just a byproduct. Period. You can say and think whatever you want to make you feel good. That's okay. But the fact of the matter is, this universe is very vast. I mean, look, it takes like 4 years to reach us from the nearest star. So that's a long time for us, you know. So it's a lot of space in space. you know, you got a lot going on out there. So yeah, just keep that in perspective when you're dealing with the cosmos. Peace to you there, brother. What's happening with you?
What's going on, man? Space Age African, what's going on with you, JuJu? Pseudo Killer Official, what it do?
What's good
Peace,
with it,
Man,
homie?
Bobby
you know me.
Baker.
Just
I got a good question for y'all, right?
what you got?
We hear
Uh-oh.
the pseudos on a regular basis misconstrue the wonderful, beautiful statement that says we're stardust, right? And okay, so we understand that, right? But could you expound on that, please, on why they messing it up and what is really meant by that eloquent, nuanced statement? Could you explain that?
Yeah, man, it's a shame that you know we have to go through that, but basically the elements that make up humans, the calcium, the everything, the hydrogen, the H2O that makes up the water, all of these elements that we know of are forged in stars. So when when a star goes through its different phases, you know, that core, it builds up like a shell. You know, you have layers of those elements after it gets done fusing hydrogen. If those hydrogen atoms become, you know, compressed together due to the gravity and the heat going on in the core of the star, and it after it runs out of hydrogen, you know, it swells up, comes back down, and now if it's massive enough, it's burning helium. So all of these elements that we see on the periodic chart and these same elements that make us up are forged in stars. And the way they're distributed is through the novas and the you know, the supernovas and those things from that effect. So yes, all of what we are comes from an exploding star or a star that's, you know, gone through its evolutionary process.
Yeah.
So that's the process. You know, that's what happens. Now, like I say, it's a shame that we have to deal with, you know, those that would prefer to push what feels good to them over the truth or the way that we understand things in the real world. You know, it's a shame we got to go through that, brother. But it's I guess it's a necessary evil because it drives people like me, people like you. You know what I'm saying? Miss Juju, everybody on here. You know, it's you have a drive to want to actually get the understanding correctly and get it out there. You know, so we just got to keep doing what we doing. But like I say, it's a shame people take that valuable information and just twist it and make it to what feels good. You know,
Yeah. They think they must think we came out
God damn.
like they
Jesus
must
right?
Christ.
they must think we came out like spores or something like fungus or some shit.
That nigga
I
don't
guess
even
so.
introduce himself. He only say, "How you doing?"
I
Dive
said
in the
what's up.
middle.
Yeah,
I said what's up.
Jesus
What's good?
Christ. Jesus Christ. Mm.
what's
Let me
happening
finish
with you,
my
brother
point. Then
Gully?
you can go ahead, Gullah. Let me finish my point. Um, I think the irony in the whole thing is you just talked about. You know, the chart you showed, the element charts and the times when these elements came into play, right?
Right.
Once you get past that process, stellar evolution, the whole 9 yards, and then life gets to Earth, then it has to evolve to end up at the point of Homo sapiens sapiens. So the very people that claim and talk the whole Stardust thing, right? In their mind, they think they saying something that's super spectacular that actually usurps Charles Darwin evolution, but it actually don't, because the two go hand in hand to end up to get to humanity. So it's wild how they accept the fact that we're stardust, but don't accept the fact that we have evolved on planet Earth. I just wanted to add to that. Go ahead, Gullah.
Yeah, I like the way you put that. Was dope how you put it. Like how you put that. It's basically like we the debris, like the leftovers of the of the explosion. You know what I'm saying? Like and like
Yeah,
we're beautiful. We'll be considered a beautiful mistake. You know what I'm
Right.
saying?
yeah.
Like that,
I'm with you on
everything.
that, man.
It ain't no real reason. Like it is what it is.
Yeah.
Yeah, we're just a byproduct. We're a byproduct of all those different explosions, all those different processes that created or forged us, you know,
Yeah.
the
Right.
elements that make
Forge.
us. You know what I'm
Use
saying?
forge.
So,
Yeah, and if it is life on another planet, it wouldn't be nothing ever that we had imagined. Like it'd
yeah,
be something totally different. There definitely wouldn't be no vertebrates. It probably wouldn't even have a brain, because all that stuff was developed on our planet, the nervous system, and all that development was necessary and complementary to the environment and the climate and the ecosystem that was on this planet and what happened during that time course.
yeah,
Interesting.
that's a fact.
Ju-
Great points.
Juju,
Yes.
how would you explain it?
I mean, Anthony
I want to hear
explained
the
the
way you
best.
put it together. Huh?
Anthony pretty much explained it the best, but I think they're getting it confused because, you know, all the elements, all the necessary components that it took to create, you know, life on Earth in particular are products of the universe. And I don't know, it's a feel good type thing instead of, you know, really understanding the mechanisms that, you know, come into play in that process. People just, you know, what we always say, like to microwave the information and kind of make up their own feel good stories about it. I mean, it sounds good, right? It definitely sounds good, but it's just more than just being, you know, mere stardust. There's I don't know, would I even call it dust? Because we just spoke on this whole phenomena that, like, how do these elements even come to play or being forged? Like, there's a process that scientists are still trying to figure out as we speak. So I wouldn't even say that we're mere stardust. We're more than that. You know what I'm saying? If you really want to take it there, much more than that. But we don't even know.
Forged by destruction, huh? Things have to
Or
get destroyed.
wait. But see, that's perspective. Because is it destruction or is it a birth? You get what I'm saying? I mean, but
I,
that's the cycle of life and aspect. Like, you know, things are destroyed, things are birthed, things are you know, evolve or created out of that which is destroyed. Even when we talk about forest fires, they can be devastating, but they also have an impact on bringing like new flora and, you know what I'm saying, a whole new ecosystem. So it's perspective.
Yeah,
Uh,
even mass extinction. You know, so you get new life out of mass extinctions, and you know,
Right.
you have bottlenecks and things in that nature.
Right.
Yeah, and
well, Miss
and
Juju,
oh my
Yes.
bad.
Miss Juju,
Yes.
that picture you got up there right
Yes.
now,
Hmm.
it's great how you got that blowed up.
I tried. I got it. I
I
figured it out, y'all. One
I took that
technological step at a time.
I took that picture yesterday morning before I
Woo!
went to work. I pulled my stuff out
You're a
about
bad mama.
3:30, and I got like 16 3-minute exposures. But can you see that up here at the top, the dark part? See, that's dust that's actually blocking that nebula. That's the Orion
Okay.
Nebula.
Right.
You know what I'm
Do
saying?
you see my area? Are you talking about like right in here? Or did I blow it up too much?
No, you good. It's right there at the top towards the right. You see that that's dust, and you can see the detail in this picture. All the different gases. You know, that's the Orion Nebula. Like I say, it's about 1,500 light years away from us. But that's a star forming region. Those are stars that are being born from all that gas and dust. And where you have stars, you likely have planets. You know what I'm saying? And that's going to lead into our next show. You know, we're
Hmm.
going to talk about that area right there, the Orion Nebula. We're going to talk
Right.
about that and what James Webb has shown us about that actual particular area of the sky. And it's dope. I'll make
Hey,
sure y'all be here for that.
hey, Anthony, is the you ever use like Google Maps, like not Google, like Google Star Maps? Do you know if that's accurate or not?
No, I've never used that one. I like to use one called Stellarium. Stellarium is pretty good.
I'm gonna check
And
that out. I'm gonna check that out. And
yeah,
to
it's dope, man.
I'm gonna add on to that. Like you said, like everything you see on the on the table, like that's us. Like all the elements that you is all in the store.
Hmm.
Like everything in the universe is it's like one big or one big combination of different chemical reactions. Like we're chemicals too.
Right.
Yep.
Like chemistry is the breakdown of biology. Like if you keep breaking down biology, you get to chemicals and chemistry and stuff.
Yep.
Even
Yep.
even the
You're
air we
absolutely
breathe
right.
is chemicals.
Yep.
Yes, we
You're
are
absolutely right.
sayings. Something comes from something. Yes, we're saying
All right, Mr. Perkins, you was doing good. And yes,
that.
we came from stars. That's where we come from. And like I say, on this picture here, you can see the different layers of the gases. You can see that dust. You know, this is the type of quality that I want to bring to y'all. It's gonna get better, you know, because I'm learning how to operate this stuff. But it's 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 going down. So if you can't get you a telescope or whatever, that's okay. I got you. I got you. You still gonna be able to enjoy, you know, the the views. You might not be able to see it yourself, but I recommend if you can get you one, get you a telescope. It will humble you. I promise you, it's gonna humble you.
We also got DQ Hampton in the building. Peace, Little Kill Official. If you want the, if you had a few comments or any
Peace
questions.
to you, DQ.
Man, peace, peace. I'm sitting back. The skies is one of my favorite things to analyze, and I appreciate Anthony because he got me back in the love for it. But
Right.
most definitely, I love this right here. This basically, like I'm saying, when you're looking at stuff like this, you're basically looking back in the time, and
Mm-hmm.
people have to understand the evolutionary process, and everything is a step process, and you can't skip a step. Like we're gonna
Nope.
keep reiterating it. There's certain reasons and aspects where you can say we are Stardust, but like you say, we're a lot more. We're just waiting for that to be uncovered. So yeah,
Mm-hmm.
this is definitely some great information and beautiful shots, brother. That's something you can sell to a magazine, baby.
Right?
Sell to a
I
website,
appreciate you,
man.
man.
Look,
Yeah,
Appreciate
come
you.
on,
this look like
sponsorship. Come
this,
on. Come on,
this is like it came
sponsorship.
straight out of this is like it came straight out of Scientific America, like
It
for
You
real.
know
does.
what I'm saying?
Nah, that's me,
Phenomenal.
dog.
That's
That
Starman.
that
That's Anthony. That's
yep.
Starman. Space Age African #1, ladies and gentlemen. Anthony
Nah,
Bowman.
I appreciate that, y'all. I really do. This this is the gratification I get. You know, just having people to want to talk about it, want to learn about it, and you know, just enjoying what I do. Man, it don't get no better than that. So I appreciate all of y'all on
I
everything.
think we
I really
appreciate you
do.
more. I think we appreciate you more.
Oh man, look in the comments. It's dope because this ties into a conversation we had the other day. Peace to
What?
Queen Gemini. She said it looks like a gorilla face on the side. You know how humans always
Oh,
Mm.
try to find that
patternicity,
face, yeah, within
the
anything. So yeah,
patternicity of the
that
brain,
is dope.
right?
That's exactly
Yep,
how the constellations was formed. Just by looking at it like
Exactly.
that.
Yep.
that boy,
Facts.
Recognizing
everything
them patterns.
is 360.
Because
Peace to
if
the
That's
you
Queen
look at a
Gemini.
if you look at a constellation from a different view, those stars are nowhere near each other. They
right.
are light years away from each other themselves, not just us, but from each other. So, but like you were saying, the patternicity. We look up in the sky and we see a pattern, and we, you know, as humans, when I say we, I'm speaking of as humans, we notice
Right.
it looked like this, and that's what we call it. You know, just unfortunate that majority of what we know are the names of things is Greek. You know, you have a lot of Arabic too, but the mainstream stuff mostly is Greek. And you know, we can change that. You know, that's on us. That's nothing that's set in stone. You know, you don't have to call the constellation Orion Orion. You don't have to. You know what I'm saying? That's something we can do for ourselves. And by
Oh,
taking these pictures,
Anthony,
that's something we can do. You know, we
you
have the
just
right to
got
do that.
you just gave me an idea, bro. I want to start mapping out the constellations and all the great hip hop artists. Like this is the constellation Nas, this the constellation Hov, this the
Well,
constellation
I'm gonna
Biggie.
tell you something. Hey, I ain't got no problem with that DQ, especially for this book. But the constellation Orion is off limits, dog. I got big plans for that constellation there.
Oh, y'all
Yeah,
funny right
right.
now.
Yeah.
So we
That's
finna
dope.
change the name of
Already.
that joker, there, dog.
That's pretty
Let's
Soon
hot.
as I get
go.
a picture of it, hey, and y'all gonna love it too. I promise you, you gonna love it. I've been thinking about it for about 6 months, dog, and it's
Oh,
going
that's
dope to
hard.
me. So,
Shit, I'm
but
behind you,
all the
baby.
rest of them DQ, all the rest of them DQ, it's all gravy with me, baby. We'll put it in the book, and that's the name. Matter of fact, it was a posterior thought. This right here, we gonna change the name of that. I just
I
want to make
love it.
sure it's. I just want to make sure it's okay before we advertise it. But he gave me a beautiful sister, African American woman that we're gonna name this one. This picture right here, we're gonna name after her.
So funny.
So
Oh,
So,
Orion, and if you're listening, posterior thought, peace to you, and I appreciate that. But DQ, that Orion, nah, I got a name for that one.
yeah. That's
I
what I'm
got a
talking
name for
about.
that one.
I also
This is
want.
what I mean. Do you think, Juju?
Oh no, I just kind of wanted to also, point out some things because, I'm about that African American history and the significance, um, and the respect that we definitely should give our ancestors because, the cosmos was one of those things that they took and they studied and they learned, but they also use it as a tool. And they basically used it as a tool to find freedom and liberation from their oppressors once they were brought here to the new world. And that's something that I always think about when I'm veering up to the skies. Those who came before me, those who fought for, freedom and liberation. When we think about the Big and Little Dipper, we think about the drinking gourd, right? And those things we definitely need to pass down and share and not forget um, what that actually means. And also the beauty in it, because it was a thing of beauty and wonder, but it also was a thing that, gave us our freedom. That's something I think about all the time. Every time I go out to look at a celestial event, you know, Harriet Tubman crosses my mind. The drinking gourd always crosses my mind. So there's lessons in history and everything, and that's the beautiful part of all this in this journey.
Yeah,
But
for sure.
if you want to give any final remarks, because we're at the hour and a half mark, and we don't want to make this long, and we do have a lot more to bring to you in the future. But we definitely want to keep the show within its respectable limits. So, any final remarks from the panel?
I just want to say peace to everybody. This is some good information for everybody to, ingest, and you can also apply this in many different ways. So, yeah, peace and blessings to the family. Pseudo killers kicked out policy. Yay, yay.
Yeah, DQ Hampton, Pseudo Killer Official. Hey,
Oh yeah.
uh, Gullah, any final remarks?
What's good? We out, fam. I would say, if y'all really want to be scientific literate, just stick to it. Stick to the research. Don't go off the rails trying to be, get into some pseudo wormholes. You know what I'm saying, or rabbit holes or whatever. And I can't wait to see what Anthony gonna name Orion. It's gonna be dope.
Right?
I got a suggestion myself. I think you should name the Gwen
Ooh,
after Gwen Dickey, who sings "Wishing on a Star" from Rolls Royce.
ooh,
That'd be dope.
wishing on the star,
Mhm.
dim, dim,
Yeah, that'll be nice.
and
There,
that's where you
that'll be nice.
are, dim, dim. My bad.
But yeah, I think y'all gonna like what I got. It's pretty dope though. I think it
All right,
is.
I
I
bet.
hope y'all like it. I hope y'all do. But as soon as I get a shot of it, I want to get a picture of the whole constellation. So that when I get that, like I said, and it won't be too long. It won't take Probably next weekend when I can get dark skies. When we get close to new moon, then I should be able to get the whole constellation in one shot. Cause I just use my camera, my DSLR camera. So, but I think y'all gonna like it, man. I think y'all gonna like it. But anyway, you want to say something, before we get out of here?
Bobby Banger playing with Killer right now.
He done went to sleep.
No,
But
you playing
it
with
was.
Killer right
Oh, he out there with his gray wolf.
now. What is great? He went to Great. Color, that was funny, bro. His name- I'm sorry. Boy.
But
Well,
I just want to thank you, Miss JuJu, for
absolutely.
another great production.
Yeah.
I appreciate you and the work you putting in as well. So most definitely, it's just what keep me going. So y'all are my drive, my inspiration.
Likewise.
Yeah,
So,
Appreciate
most
it.
definitely, but likewise.
Appreciate your brother always.
Yeah.
family, right? Space Age Africans, ladies and gentlemen. This is what it's about. I always read you all the vision at the start of our show so y'all don't forget what our mission is, but this is what it is. And with that said, thank each and every last one of you for taking the time out to join us here this evening, to be active participants in this thing that we call science. Don't forget to check that description box for the source material used for this show today, and also the link shares for the week. Remember, Pale Blue podcast featuring Dr. Moya McTeer, and also the European Space Agency. I shared with you before about NASA.com, and also they call it the children's version, but I'm not gonna lie. For anyone that may feel a little bit intimidated about this information, please go to NASA.com's spaceplace.nasa.gov. That website is pretty amazing. And if you also want to start getting outside and maybe, testing your skills in detecting or even recognizing celestial bodies or whatnot, Solarium is the phone app. If you go into your app store, I believe you can find it. If I'm not mistaken, you can find it on Google Android and Apple phones. But Solarium is the app that we most recommend. There are others, but if you want to start doing that, then yeah, go ahead and get that done. So, ladies and gentlemen, we appreciate you all. And Anthony, if you want to play us a little bit of exit musica, por favor, we'll be on our way out. Meet us next Wednesday, same
Indeed.
time, same place for season 1, episode 3. Good night.
Y'all remember what I always say: when you're scientifically literate, they can't drag you down to their level and beat you up with experience. Peace out, people.
If it's pseudo, you do know we don't entertain that keyboard judo. That big Bobby Banger out of Baltimore. Done it all, shop before. Sold a little something, but I taught you more than your average teacher. I had to reach you at your level to bring you up. No devil can never beat you. With precision of a magi, the information supplied by some guys get debunked on live. CK and JuJu, I chill in the cut. But if you boys wanna fade, then I'm chefing you up. I organize live, the beats of this. Organized truth every time. Kudos, who those niggas? Decorated pseudo killers. Space age Africans, back again. An organized lie defeats a disorganized truth every time. Kudos, who those niggas? Decorated pseudo killers. Space age Africans, tapping in. I always been fly, that's an actual omen. You can catch me in the sky, ask Anthony Bowman. He see me with his telescope. I was actually floating on some good kush. The Sabio is actually growing. See, Gullah Gullah and Kent is where the money gets spent. Them boys got some books that cost as much as your rent. The second verse should be smash rock well, but I rock well. Underground like Sumerian rock whales. In the ring like I'm the rock whale. Hell, create a different wave that can rock whales. Hell, shit swell like lunar tides. My entendres off Gandra to who describe. Euthanize foolish guys. Scholastically, haphazardly. Turn your camera on and look me in my eyes. And please do subscribe. 8 to 80, blind, cripple, or crazy. You in for a new surprise. It's DQ, a organized lie. Defeats a disorganized truth every time. Kudos, who those niggas? Decorated pseudo killers. Space age Afghans, back again. An organized lie defeats a disorganized truth every time. Kudos, who those niggas? Decorated pseudo killers. Space age Afghans, tapping in.